My name is Ben Davis-Purcell, and I'm a fourth-year undergrad physics student from McMaster University. And I'm going to be answering the question today, how are the northern lights formed? So, for this question, they are entirely formed due to interactions between the sun and the earth. So here we have a diagram of the sun and the earth. These are not drawn to scale, obviously. So the sun always, at all points in time, is emitting particles, sometimes stronger than others. But one of the ways that it emits particles is through something called the solar wind. So you got the sun emitting particles in every direction. Most of these are electrons. And so obviously the earth is going to be in some direction of the sun. So some of these particles are going to be hitting the earth, some of these electrons. So now there's particles from the sun going towards the earth. Now it turns out the earth has a magnetic field, as some of you may know. That is how our compasses work. So the earth can actually be modeled as a magnet with a north and a south pole. So if we draw that on the earth, let's say in this diagram, the north pole is here and the south pole is here. That creates magnetic field lines that, if you drew them, would look something like this, coming out of the earth, where they start at the north pole and then go down towards the south pole, ending at the south pole. Okay, so they extend very far out. These are just a few of them, but they're everywhere in space. Okay, you can go all the way out here, curling all the way from the North Pole to the South Pole. Now, when charged particles are traveling and feel a magnetic field, a force then results from that, and now they respond to that force and move differently. So all these electrons that are traveling in this direction then hit this magnetic field and feel some sort of force, and then change direction. And because of the spear-like pattern, they change direction in different ways based on the area of the earth they hit, and the area of the magnetic field they hit, and where they're emitted from the sun. So it turns out that then this creates something called a magnetosphere in this area right between this interaction point. So if we draw that right here, it's something like a cone-like structure like this, which is in there. So that's the magnetosphere. So then you get this area created called the magnetosphere that is the area of interaction between the sun's emitted particles and the Earth's magnetic field. And how these interact when you have then electrons in this magnetosphere that have their velocities changed and their characteristics changed due to this interaction with magnetic fields, continuing through Earth's atmosphere and passing through various layers, hitting different particles in our atmosphere, such as nitrogen or oxygen, then you get colors produced from the way the electrons hit these nitrogen or oxygen based on different altitudes in the atmosphere where these nitrogen or oxygen particles, as well as some others, are hit. So, for example, maybe from up high, if you hit a nitrogen particle, you might get a blue color, different if you hit one down low, or an oxygen or something like that. But that is how the colors are created. You can go into more depth about what colors are actually created where, but the reason that we get northern lights is entirely from this sun-earth magnetic field reaction and electrons moving through the magnetosphere, hitting particles in our atmosphere to create these colors.